So here we are again, working with the data to determine if our data here is parametric or not. So just a reminder, I've kind of moved these down just a little bit to get them out of our way, but we already know the data is interval. We've confirmed that the data fits within the skewness limit, and we have confirmed that the data has a relatively decent bell-shaped curve. So I have all that information here from previous videos. So what I'm going to show you now is how to determine if roughly 67% of your data fit within one standard deviation, and whether or not the mean equals the median equals the mode. So over here is some information about how to kind of really check this. And honestly, it's going to be rare that your data is right at the 66.7% or whatever. But if anywhere in the range of 60 to 76% of the value you get from here that I'll show you how, that's probably within reason. So that's relatively one standard deviation being in that 66.7% range if it's within 60 to 76%. All right? So first thing you need to do is figure out what your average is, and with our descriptive statistics we already have that. So here's my mean. Now you could also just calculate that using your standard average calculation using Excel. Either way, one thing I do want to point out now so I don't forget is these numbers are static. So if you've done the average down here, if I change the data, or if I realize that this number was incorrect and that number was actually 90, I'm using a huge number just so you see it changes, then all these values are going to change appropriately, right? However, this is static data. This is whatever the data was when you did your descriptive statistics. So if you want data that can change, you need to use this average and this standard deviation. And you can perfectly do that down here. I just want to make that point. I'm going to use these values here just so I can show you what's going on. So if I want to understand my range for plus or minus one standard deviation, this should actually be mean minus a standard deviation, then I need to make those calculations. All right, so for my mean plus one standard deviation, I'm just going to calculate my mean plus my standard deviation, and this is the standard deviation value right here. Right? Do not use the standard error. Right? So if you are using that standard error, you are going to be incorrect. Standard error is a completely different value. You can see it's a lot lower than standard deviation here. Standard error is actually the standard deviation divided by the square root of your replicate numbers. So in this case, divided by the square root of 50. Standard error should not be used. It's very different. Use the standard deviation. So make sure you are using standard deviation, not standard error. Right? So in order to get my mean minus one standard deviation, just do the same thing. Mean, only this time I'm subtracting the standard deviation from it. And there's my range. So anything that falls between 3.32 and 7.11 is within one standard deviation of this data. So I need to now use Excel to figure out how many of these data points fall within that range. In theory, I could just count. Is that between the range? No, there's one. There is, nope, two. And I could count along the way. But I want to make Excel do this for me, because there are times in science where you are literally going to have thousands of data points. And you are not going to be able to count. It's hard enough with 50. You don't want to do that with thousands of data points. So how do I do this? This is where this calculation over here on my PowerPoint, this is where that calculation comes into play. All right? So this function, again, not very intuitive, but I'm going to put equals. And I'm going to use a function called count. We've used count before. Now I'm going to use count ifs. If I only had one criteria, I would say count if this is below 5. And it would go through the data and only count that number if it was below 5. But I have two criteria that I want to make. I want to count it if it is above this number and below this number. So by counting it if it's above this and below this, I'm counting if it's in the range of our plus and minus 1 standard deviation. So how do I do that? I need to count ifs in my criteria range. I need to count this data if. All right, so there's my first criteria range, comma. And then what's the criteria? So the criteria for this one is want to count it if it's greater than or equal to. So if I'm telling it something, I need to put it in quotes. Quote, greater than or equal to, end quotes. I want to count if it's greater than or equal to. And then this is the part that really doesn't make any sense, but you now need to put an and there. That tells Excel that you are done giving the relationship. So that relationship could have been equal, could have been less than, could have been whatever. We put greater than or equal to. And now I'm telling it what value I want it greater than or equal to. So I want it to be greater than or equal to this value. And so now I'm ready for criteria 2. I'm still using this same data. I want to know if that same data is, now it needs to be, so I put a comma because I've done with my data range. Now I need to know if it's less than and this value. I have to include one of those values but not both, because if I include both of those values then I'm making my standard deviation actually bigger. So I need to make it greater than or equal to my lower range, my lower value, and less than my upper value. So when doing so, let's take a look at this. There's my range, right? So this value here, that's my range of data. This is saying I want it to be greater than or equal to this value. So I want it to be greater than or equal to my mean minus 1 standard deviation. And then I want that same set of data to be less than my upper limit, which is the mean plus 1 standard deviation. Right? So if it's greater than or equal to the lower value and less than the upper value, it's within this range. So that would mean I'm counting that data point if it's within 1 standard deviation. So when I click that, it tells me that I have 34 data points within 1 standard deviation. So that doesn't tell me percent though. All I need to do there to get percent is divide the value I got by my count. And again, this count is static, so if I wanted a count that would change if I add data or whatever, I would want to use the count down here. But then I also would have wanted to use the standard deviation, everything down there. So to get my percent, I'm going to put that in there. And this tells me that 68% of my data fell within 1 standard deviation. So does approximately 67% of your data fit within 1 standard deviation? I'm going to actually add here, basically I'm going to give you the range that you want. So you're basically looking at 60 to 76%. And so the answer here is yes. 68% of the data fit within 1 standard deviation. All right. So as you go through this and you're practicing on your own homework and on your own work here, use this slide that I've provided for you because it's going to talk you through all the different parts of those things. All right. So the last thing I need to do is, does the mean equal the median equal the mode? And I am going to put a big red thing there because I do not want to use that mode. Basically that is telling me that the number 5 showed up the most times in here. All right? But remember, this is continuous data, so the fact that the 5 showed up several times in there is simply because I was measuring really to only 1 decimal point. Those would be 5.0. So how do I get the mode? Remember, this is where I was saying the mode is actually the middle value of the range of the bin with the highest frequency. So here I have 2 bins that have the highest frequency. These are my 2 bins. They both have 10. Right? If only one of them had 10, I would use the middle of that. So the reality is my range really is 4 to 5.9, because 4 to 5.9 actually is the full range because those two are next to each other with the same mode. All right? If I had had one of these that had 11 instead, then I would use that one and I would say, let's say 4 to 4.9 had 11. I would use that bin as my mode, and I would say the mode is 4.5. Okay? But as it is, since these are right next to each other, the middle range of those bins with the highest frequency, it does actually end up being 5. Right? So in this case, it turns out to be the same number, but that is basically an anomaly. You have to go through this thinking to get the mode. Right? Find the bin that has the highest frequency, and then use the middle value of that bin. So, if the mode equals 5 from bin with highest frequency, not from my descriptive statistics, then this is, answer is yes. Basically, because my mean is 5.2, median is 5.05, mode is 5, all very similar. So for this data, I would say that I definitely have parametric data. I can go ahead and use parametric statistics because I've fit all 5 of these parameters. So when you're doing this on your homework, make sure you're doing all of these aspects of the Excel that I taught you. Use the data here. If I go over here, I can even show you that I reminded you not to use that mode, but use the mode of the bin with the highest frequency. Right? And make sure you actually have this type of information. So at the end of your homework, kind of have each of these parameters and really talk me briefly. You don't have to put a lot of information, but talk me through your analysis, yes or no, and why. And then you'll be fine. All right, I hope you're able to do this well. Contact me if you have questions, and thank you.